Good morning, students. Whether my screen is visible, I am audible. Yes, correct.
Yes, sir.
Correct. Good morning. So, welcome to the module 40 in the IC engine subject, right? So, we are in the unit 5, right? So, modern technologies in IC engines, right? So, why we have to use the modern technologies, right? So, for the mainly two reasons we are going for the modern technologies, right? We have to uh, doing some research, right? Still is going on, right? So for the two major conditions, right? One is the emission, right? So we have to reduce the emission, right? So which is produced in the engine, right? So particularly the NOx emission will be high in most of engines, right? So we have to reduce the NOx, right? So by using the catalytic converter, we can control some hydrocarbon emissions, carbon monoxide and carbon dioxide. That hydrocarbon emissions we can somewhat control by using the catalytic converter. But during the combustion, some unburned fuel will be there, right? So due to that unburned fuel, we can get the NOx emission, right? So that's a very dangerous and harmful one, right? So we have to reduce particularly the NOx emission, right? So that's the main term, right? So that's the main problem, right? So we have to reduce the emission. That's the first one. The second one, the fuel consumption, right? So in early days, uh, the fuel consumption will be very high, right? So we have to reduce that fuel consumption also. We have to reduce the fuel consumption to get the same efficiency, right? So to get the higher efficiency at lower fuel consumption, right? So that main 2 points. One is the emission and second one is the fuel economy, right? So due to these two reasons, we are doing the research for the modern technologies of an IC engines, right? So uh, in the modern technologies, we have plenty of solutions. Still the research will be going on, right? So in that modern technologies, just we have seen what are the modern technologies which is available in nowadays, right? So the first one is the HCCI engines, right? The last class we discussed about the HCCI engines, right? So in this class we are going to see about the common rail direct injection, right? So you may heard about the CRDI engines. அதை கேள்விப்பட்டிருக்கீங்களாப்பா? CRDI engines. Even the car, right? So car back sideல போட்டிருப்பாங்க CRDI அப்படின்னு போட்டிருப்பாங்க, இல்ல TDI அப்படின்னு போட்டிருப்பாங்க, இல்ல DDIS. அந்த மாதிரிலாம் வேர்டிங் பார்த்துருக்கீங்களா காருக்கு பின்னாடி? Anyone?
Yes, sir.
எஸ், நீங்க பார்த்துருப்பீங்க, ரைட்? ஸோ ஃபார் எக்ஸாம்பிள் இப்போ நீங்க மாருதி கார்ஸ்லாம் எடுத்தீங்க அப்படின்னா மாருதி CCIR போட்டிருப்பீங்க, ரைட்டா? ஸோ இப்போ மாருதி கார்னு எடுத்துக்கிட்டீங்க அப்படின்னா பின்னாடி நம்மளுக்கு என்ன இருக்கும்? நம்ம மாடல்ஸ் ஏற்ற மாதிரி இருக்கும். LXI, VXI, ZXI ப்ளஸ். ஸோ அந்த மாடல்ஸ் வெரைட்டிஸ்லாம் இருக்கும், ரைட்டா? ஒரு சைடு. ஸோ இன்னர் சைடு பார்த்தீங்கன்னா வந்து DDISன்னு போட்டிருப்பாங்க, இல்லை வந்து TDSன்னு போட்டிருப்பாங்க. அந்த மாதிரிலாம் வேர்டிங்ஸ் பார்த்துருப்பீங்க இல்லையா? ஸோ தட் என்ன that term also indicates this term, right? So the generally used term is the common rail diesel injection. The common rail direct injection system will be there, right? CRDI, right? So CRDI, right? But in some companies they are specifying their own name, right? So most of the companies they are specifying their own names, right? So like this. So different companies will have the different name, but the meaning will be the same. Right? So you may see this type of the names at the back side of the vehicle, right? So இதெல்லாம் பார்த்திருக்கீங்க இல்லையா? So most of you may see this one. இதெல்லாம் பார்த்திருக்கீங்களா? Just anyone reply?
Yes, sir.
Yes, right. So for example, most of நம்ம பார்க்கறது நிறைய மாருதி போயிட்டு இருக்கும். So DDSI, you may see the plenty of cars, கரெக்டா? ஸோ இதெல்லாம் பார்த்துருப்பீங்க. பட் Hyundai cars we are CRDI, ரைட்? அதே மாதிரி Tata Motors CR4, and some Tata Motors we have Dakar. Right? So in the Mariana notations எல்லாமே நீங்க பார்த்திருப்பீங்க. Right? CDI mostly பார்த்து Benz car எல்லாம் பாத்தீங்கன்னா பின்னாடி சைடுல போட்டுருப்பாங்க CDI. Right? So all these terms refers the same, right? So all these terms will refers the same, but for the different company they have using the different names or different notations they are using, right? But the same, the concept will be the same, right? So what is that? The common rail direct injection system, common rail direct injection system, right? So what is the common rail direct injection system? The common rail direct injection system will be used in most of the diesel engines. It has most of the diesel engines we are using that common rail direct injection system, right? But in some petrol engines we are using GDI, that is gasoline direct injection, right? So நம்ம டீசல் இன்ஜின் யூஸ் பண்ணக்கூடியது என்னது CRDI அப்படின்னு சொல்லி யூஸ் பண்ணியிருப்போம். இதே நம்ம வந்து பெட்ரோல் இன்ஜின்ஸ் யூஸ் பண்ணும்போது வந்து GDI அப்படின்னு சொல்லி யூஸ் பண்ணியிருப்போம். Correct? Right. So that you may remember this one, right? So the common rail is a fuel injected system which is used in the diesel engines, and it basically works as the synchronized injection via a common pipe or a common line, right? That common line is called the common rail, right? That line is called the common rail, right? So in CRDI engines, right? So there is a common line, right, which is called as the common rail, right? So each injector is connected to the common rail, right? So each injector is connected to the common rail. Through this line the fuel is sent into the cylinders, right? But in conventional diesel engines the pressure needs to be readjusted for the each injection process, right? This is the diagram. You may just listen, just you can understand this one, right? So for the traditional or olden diesel engines, right, older diesel engines, the pressure needs to be readjusted for each injection process. So while in CRDI engines, the pressure is always constant, right? So here you can see the red color, right? So this red color is there, no? So this is the common rail, right? So it's a small storage of tank. It is a small storage of a tank, right? So that tank is called a common rail, right? So through this common rail we have to connect the injector, right? Right? So for the multi cylinders we have multiple outlet, so we have to connect the multiple injectors. So each cylinder will have an injector, right? So that injector will be connected through this common rail system, right? So in this common rail, the pressure will be the constant one. So here it is the important one, right? The pressure will be a constant, right? So in CRDI the pressure is always constant, and this pressure remains constant along the fuel line, right? So the pressure will be constant in the common rail, right? So here we have a control unit, right? So this control unit is called the electronic control unit, ECU, right? So ECU, right? So this control unit adjusts the fuel injection timing of the injector. It depends upon the various engine speeds and the various engine load, right? So here you can see the acceleration pedal, the engine speed, then the engine speed, that is engine speed, and the crank speed and the cam speed, and the load conditions, right? So all will be sensed, and the sensor data will be sent to the ECU unit. That ECU unit will control what are the amount of fuel injected through the injector, right? So here the connection will be there, right? So the ECU unit sends the signal to the injector. So how much amount of the fuel has to supply in the injector, right? So the ECU unit is a very important one in CRDI engines, right? ECU unit is a very important one for the CRDI engine, right? So the ECU unit adjusts the injection timing and injection timing of the injectors. It depends upon the various engine load condition as well as the engine speed condition, right? So the amount of fuel is to be delivered to the combustion chamber is controlled by the ECU unit, right? It is set by the ECU unit, right? So the ECU unit gets the information through the various engine sensors, right? So gets the information through the various sensors which is present in the engine system, right? Then the fuel is supplied to the combustion chamber when it is needed. The fuel is not sent to the combustion chamber when it is not needed, right? So the fuel cutoff will be very good, right? So why? Because it is controlled by the electronic control unit, right? So when the combustion chamber required the fuel, then only the fuel has to supply through the injector, otherwise the fuel will not be supplied, right? So it is controlled by ECU unit, right? So it will reduces and it will saves the fuel, right? It will reduces the emission and it will saves the fuels, right? So this system is mainly for the emission control, right? This system is mainly for the emission control. Why? Because if we are supplying the more amount of fuel into the combustion chamber, so then it is a possible to accumulate the fuel in a particular places, right? So if it is accumulated in a particular places, what will happen? The knocking will be produces while burning the accumulated fuel, right? While burning the accumulated fuel, it may causes the knocking, right? And some cases, what will happen? The more amount of fuel will be there in the combustion chamber, right? So at that time, some fuels will be the unburned condition, right? Some fuels will be the unburned conditions, so that will be removed by the exhaust manifold, right? That will be removed by the exhaust system. So sometimes the unburned fuels also come out from the engine, so the NOx condition will be produces, the NOx condition will be increases, right? So we have to supply a correct amount of fuel. We have to supply the correct amount of fuel, means it will saves the fuel, that's the main one, and it will reduce the emission, right? So if you are supplying a correct amount of fuel into the system, into the combustion chamber, means it will saves the fuel. That's the first one. The fuel economy will be good, right? At the same time, the controlled amount of fuel will be sent to the combustion chamber, so it will be burns completely, right? So the control amount of fuel will be sent to the combustion chamber. So most of time we are sending the lean mixture will be there, right? In the combustion chamber we have supplying the lean mixture. Once we have supplying the lean mixture, so that lean mixture fuels will be completely burns and the emission will be reduces, right? So if the fuel will be completely burns, means we have to get only the hydrocarbons, then the carbon monoxide, carbon dioxide, that type of emission will be produces. So it will avoid the NOx, right? It will avoid the NOx. So why? Mainly the NOx will be produced. When it will be produced means if the fuel will be the unburned condition, when the fuel will be in unburned condition, then the NOx will be produces. But here you can see we have to supply a correct amount of fuel. We have to supply a lean mixture. So what will happen in the combustion chamber? The fuel and air mixture will be burns completely. So it will avoid, it will reduce the NOx emission. It will reduce the NOx emission, right? Is it clear? Is it clear or not? So our objective is we have to reduce the fuel consumption. We have to reduce the fuel consumption. That's the first objective. And our second objective is we have to reduce the emission, right? So both will be satisfied here, right? So this type of engine will control the emission by supplying the small amount of fuel, that we supplying the lean mixture. We supplying the lean mixture, so the NOx is reduced. The NOx is reduced. Right? Is it clear? Anyone? Is it clear?
Yes, sir.
Okay, right, fine. Then the fuel measures is more accurately we have to send through the injector, right? So the it is a very important one, right? So it is a very important one, right? So we can see how it can be works, right? How it can be works, right? So it's in diagram itself you can says its working principle, right? So from the fuel tank, right? So here it is the fuel tank, right? So from the fuel tank we have a strainer or a pre-filter, right? So it will remove the dust particles uh, which is produced in the fuel. So it will be filters and it will be sent to some pump, right? So it is called the higher pressure pump, right? So the high pressure pump will build up the pressure, right? Will build up the pressure, and the pressure has to send to the common rail, right? So in this common rail the pressure will be a constant one, right? In this will be a constant one, right? So that high pressure fuel will be sent to the injector, then the injector injects the fuel to the combustion chamber, right? So here we have the yellow lines, right? So the yellow line will indicate the low pressure, right? The yellow line will indicate the low pressure, right? So sometimes the ECU unit will controls the amount of fuel will be supplied to the right. So the ECU unit, here you can see the ECU unit will be controlled by the injector unit will be controlled by the ECU unit, right? So in that ECU unit, so there it will specify what amount of fuel has to supply, right? And at what pressure it has to be supplied, right? So in the common rail the pressure will be the constant one, right? The common rail it will be a constant one, right? At the constant one means it will be having the high pressure, it will having the high pressure fluid, the high pressure fuel will be inside in the common rail system, right? So the high pressure fuel will be supplied to the injector, right? So here what is the amount of fuel has to supply and what is the pressure, that will be set by the ECU unit, that will be set by the ECU unit. So the remaining pressure will be sent back to the tank, right? The remaining pressure will be sent back to the tank, right? So it is one concept, right? So here we have some pressure control valve also, right? At the end of the common rail system we have the pressure control valve, right? So in some cases we have to reduce the pressure, right? We have to reduce the pressure in the common rails tank, right? So there we can control the pressure by using the pressure control valve, and the excess pressure will be sent again to the fuel tank, sends against to the fuel tank, right? So it is the working principle of the common rail injection system, right? So here what are the components are there, you can see here the fuel tank, the fuel filter, then the high pressure pump, and the common rail system. That common rail system will be connects the each injector in the each cylinder, right? Then we have a pressure control valve at the end of the common rail system, right? So common rail system, right? So these are the components and these are the working, right? So how the CRDI engine will be works, right? Is it clear? Is it clear or not? Yes. Okay, right, fine.
Yes, sir.
Then we have some feature technologies, right? We have some features of the CRDI engine technologies, right? So here the emission is a problem, right? So for the conventional diesel engines, the emissions problems is always been the problem for the many diesel engines, right? Many diesel engines, and the other important problem was the customer were constantly looking for the fuel economy, right? So constantly looking for the fuel economy of the engine. So it will be for the lower fuel consumption, right? So the main two reasons, right? So one is the emission and second one is the fuel economy, right? So the emissions problem was solved by this diesel particle filters and the catalytic converters. We have to reduce the emission control, we have to reduce the emission controls, right? But in this but in most of engines we require the more spaces, right? We require the more spaces. So the researchers will decide to reduce the space of that particular technologies, right? So that is known as the fuel must be burned completely to get the higher efficiency. That's our ultimate aim, right? Why? Because we have to reduce the emission, we have to reduce the emission, right? So most of the NOx level is also decreased when the fuel is completely burned, right? So if the fuel will be completely burned means we can get a low NOx condition, we have to get a low emission conditions, right? So but it is possible at high speed engines, but it is possible in high speed engines in some cases, at the low speeds, right? At some cases, at least the low speeds, it is almost impossible to burn the fuels in a complete manner, right? So it is impossible to burn the complete fuel, right, in low speeds, in particular low speed conditions, right? So we can reduce that NOx also. We have to reduce the emission at low speed also, right? So for that we have chosen the 5 stages. We have chosen the 5 stages, right? So it will be achieved, right? So for the low speed engines also we can reduce the NOx level. We can reduce the emission level, right? So how we can reduce the NOx level means we have to prefer the 5 stages, right? So these are the 5 stages you can see in the screen, right? So for the multi-injection system, we have the 5 stages. So what are the stages are there? You can see first one is the pilot injection, right? You can see here the first one is the pilot injection. Right. So first one is the pilot injection, and second stage is the pre-injection, and third one is the main injection, and the after injection, and the post injection, right? So we have the 5 stages. We have the 5 stages, right? So why we have to use these 5 stages means at the low speed conditions, it is impossible to burn the fuels in complete manner, right? To burn the fuel in a complete manner, right? So it will causes the emission, it will causes the NOx emission. So we have to reduce. That's our ultimate aim, right? That's our ultimate aim. If it is in high speed engines, we high speed loads, right? So in that high speed condition, it is easy to burn all the fuels, right? It is easy to burn the complete combustion of the fuels, but in low speed it is impossible, or it will have some difficulties, right? So to burn the complete fuel, so we can get the NOx emission, right? So we have to reduce the NOx emission. That's our ultimate aim. So how we can reduce the NOx emission for the low speed condition, right? So by using these 5 stages, we can reduce the NOx level which is produced in the low speed conditions, right? So you may remember these 5 stages, right? So the first stage will be the pilot injection, right? So in the pilot injection occurs the immediately before the ignition, right? So pilot injection occurs immediately before the injection, right? It allows the fuel and air mixture properly, right? It will allows the air and fuel mixture in proper manner, right? So that's the first stage works, right? So the pilot injection, right? During the pilot injection, it will allows the fuel and air to mix in a proper condition. That's its work, right? So the pilot injection works will be, it will allows the fuel and air it to be mixed in proper condition, right? So that's the first stage work. Then the second stage will be the pre-injection, right? So in the pre-injection occurs, it is reducing the ignition delay before the main injection, right? So generally the ignition delay will be higher, so the fuel accumulation will be more. So what will happen if the delay period will be increases, if the ignition delay will be increases, on that time the accumulated of the fuel will be gets more. So due to the more accumulation, we can get the NOx emission. Why? Because if it is more fuel will be there, so on that time the complete combustion will not be occur. So what will happen? The NOx emission will be produces, right? So the ignition delay period has to be reduced, right? So then only we can get a smaller amount of the fuel and air mixture will be there, right? So due to the lean mixture, the complete combustion will be a possible one, right? So we have to reduce, right? We have to reduce the ignition delay period, right? So that's the work of the pre-injection stage, right? So the pre-injection stage occurs, and it is reducing the ignition delay, and it will reducing the ignition delay before the main injection, right? So the NOx level, noise, and the vibrations are reduced in this stage, right? So the NOx level, the vibration, uh, and the noise, right? And the noise will be reduced in these two stages. So the main condition is that we have to reduce the noise, right? So how when the noise will be produces, if the vibration will be more, then the noise will be increases. So we have to reduce the vibration, we have to reduce the vibration, right? So when the vibration will be occurs means, if the fuel will be accumulated more, then the knocking will be occurs. Due to the knocking, what will happen? It will create a vibration, right? So we have to avoid the knocking, the NOx level, we have to avoid the knocking, we have to reduce the knock, right? So what will happen? The vibration will be reduces, automatically the noise also reduces. Is it clear? The first two stages. Then the heat, then the heat required for the self ignition temperature, right? So that is the self ignition temperature. So in this two stage, what will happen? The heat developed, the heat generated by this stage is much higher than the fuel, that is the self ignition temperature, right? So it is beyond the self ignition temperature. So what will happen? The fuel is easily burns, the fuel will get easily burns, right? So it will develop the more heat, it will develop the more heat, so which is beyond the self ignition temperature of the fuel condition, right? So in this case, when the main injection takes place, right, the main injection takes place, that is the third stage, right? So here the fuel becomes higher, that yield, the yield will be somewhat high, the high yield from the fuel becomes higher. And for the fourth stage, after the injection taking place, after the injection taking place, and some unburned fuels is burned, right? So after the injection also we have to burn the unburned fuels. So what will happen? It will reduces the NOx condition, and finally we have to supply that post injection, right? That post injection will generate the heat, right? It will generate the heat which is required by the catalytic converter, right? Right? So by using these five stages, surely we can reduce the NOx level, we can reduce the NOx emission, right? So then if the NOx will be reduces, what will happen? The knocking condition will be reduces, the vibration will be reduced, and at the same time the noise also reduces, right? So these are the features of the CRDI engine technologies, right? So these are the CRDI engine technologies, right? So is it clear? So how we can reduce the noise, and how we can supply the lower amount of fuel, right? Then we have some advantages and the disadvantages of the CRDI engines, right? Most of condition we have some advantages, right? So for the modern technologies, right, why we have to develop the modern technology? We have to reduce the emission, and we have some fuel economy, right? So for that condition we have to go for the modern technologies, right? So in this modern technology we have some advantages as well as the disadvantages, right? So first the disadvantages, right? So the engine cost will be high. Why? Because we are using the new technologies, so we have a lot of modification, we have a lot of the sensor unit, the ECU units, right? So we have the engine cost will be high by using the several the expensive spare parts, right? So how the engine cost will be high? We are using the many sensors, we are using the many ECU units, right? So the higher technologies we are using here, right? So automatically what will happen? The engine cost will be more, right? The expensive spare parts will be there, right? Then once we are using the expensive spare parts, right? So it is the advanced technology, so we required the maintenance, right? Regular maintenance will be a required one, right? So these are the disadvantages, right? So one is the expensive spares will be there. Then due to the expensive spare, what will happen? The engine cost will be increases. Then at the same time, we require the more maintenance. We require the more maintenance, so the maintenance cost also high, right? So these are the disadvantages of the modern technology. Any modern technology engines, these are the disadvantages, right? Then the advantages, right? Then the advantages, right? So if you are using the common rail induction system, right? So then the CRDI engines, we are supplying the constant pressure fuels in the common rail, right? So we are giving the constant pressure. So at the constant pressure means it's a high pressure, right? So due to the high pressure, what will happen? We are getting the better atomization, right? We are getting the better atomization, right? So the higher fuel injection pressure, it will creates the better atomization, right? So that injection pressure created independently from the engine speed, right? So whatever may be the engine speed, right? So that the engine speed will be sensed by the ECU unit, and that ECU unit will control the pressure, right? That ECU unit will sense the signal to the injector, right? So the injection pressure will be a controlled one. The injection pressure will be controlled one depending upon the various engine condition and the various engine speed load conditions, right? Then the multi injection for the each cylinder is possible, right? So the each injector will be connected through the ECU unit. So the ECU unit will control uh, the injection supplies, right? What's the amount of fuel has to be supplied in a particular engine cylinder, right? So for the multiple injection is possible for the each cylinder, right? Then we have more power and torque will be there, right, for the CRDI engines, right? So why? Because we have get at more than 25% of engine power will be increases. Then the lower vibration and the noise level, and the lower fuel economy and lower emission level, right? So these are all the advantages of the CRDI engines, right? Then we have some components, right? The same components, right? So each component, how we can be works, that we can see in the next class, right? So up to this, you may get some overview about the CRDI engines, right? Is it clear? What is CRDI engine and how it will works, and why we are using the CRDI engines? Is it clear? Anyone? Yes. Then do you have any doubt about the CRDI engines? Do you have any doubt? No, right? So the CIDI concept is clear, right? So it is an important question in the point of examination view, right? In the point of the examination view, it is an important question. What is CRDI engines, right? So you may see, you may see these different names in different types of the companies which is produced, the makers, right? Here, what are the terms you may see in most of conditions? Is it clear? Do you have any doubt in this class? No.